Please listen. Guys, I have an important announcement to make. Okay. Just 1 minute. So listen. See, I just wanted to announce something important. Am I audible to people who are online?
Yes, sir.
Okay. Is the screen visible?
Sir.
Yes, sir. Okay. Listen to this carefully. Pay attention. Okay. I'm not going to repeat it again. So listen to this carefully. So I just wanted to share some concerns from my side. One point is, I understand that your school exams are going on, but it is at different schedules, right? So because of which, you see, you yourself are able to observe that the attendance is going up and down, right? So I wanted to emphasize on one important point. Imagine if this is going to be the status for part tests. You know what part tests are? Maybe 2-3 chapters or let's say 5 to 7 chapters that are there for the school exams, if this is the kind of pressure you people are going to undergo, in the sense tomorrow you have school exam, you're not able to attend the class today, imagine how the board pressure is going to be. Let me put the reality in front of you. The reality check is going to be starting from November, I will not get your time at all. Okay, I'll be very honest, this is going to happen because you'll have practical exams, some mock practicals, record work, or some day in your school, something or the other will come up. Okay. At the end of the day, it is your time that is going to get wasted. Due to which, the first important decision that has been taken is no more classes will be cancelled due to anybody's school exam. Am I clear with that? So nobody please drop us me or my team any message stating that we have school exams and cancellation of classes are possible. We will not do it. Is the point getting registered? We are not going to cancel anything from our side. Second important point is to have a transparency and to understand what is going to happen in a particular week. So that even if you're going to miss the class where you have to prepare for your school exam, we will give the transparency from our side in the form of a monthly calendar starting from today. Okay, this was prepared, but we have not yet shared. I'm telling you how you are supposed to have a look at this monthly calendar. Listen to this carefully. So in a month, how many classes do you have? So weekly 3. So 3 into 4, it is going to be 12 sessions. So we'll give you a clarity of what those 12 sessions are going to consist of. So if you observe this, this is a calendar that is put for the month of September. So if you look at it, we have started with this. Actually, I think I'm in sync with this, right? So 7th chapter, alternating current, I started with introduction and average value of AC. So why I'm telling this sheet will be shared in advances, if you see, I will not rush through the portions. For any circumstance, I'm not going to rush through, or I'm going to just make you say that I've completed the syllabus and make you struggle. I don't want that to happen. Okay, I cannot at least do it from my side. For that, if you see, number of subtopics I put itself is maximum 2 or 3. You would have seen the procedure by now. I will take 2 subtopics, we'll try to solve the problems if it has problems, or else we'll proceed to the next topic, right? So you will have these topics. In this sheet, everything related to that month will be clear to you. In the sense, which day, which particular topic will be handled, and when are you having holidays. I think we have shared the holiday list also. We have a parents community group in that the holidays list has been shared. Apart from that, in a month, you will have an idea of when the holidays are going to be there. For example, 6th, right, we had the Janmashtami holiday. Actually, it was not planned because most of them requested I had to give it. Okay, it was not planned in the beginning of the month. Okay, but going forward, the holidays are already planned. That schedule is given to you. So holidays will be given in one of the colors, blue colors. Okay, if it is just white, it means that I am going to handle the class. So remember this thing, for physics, actually you have 2 teachers. Who are they? One is me, and you know another teacher is there who is Adarsh sir, who will handle it only online because he's from other state. Okay, he will handle it in my absence, and mostly the handling part will be in such a way that he will only handle problems of whatever I've taught based on whatever has been taught. So if it is going to be a substitute class, if for example on this Monday I was not there, okay, but I arranged for a substitution class where I asked him to solve the miscellaneous problems and based on electromagnetic induction, and that is done, right? So, but you will have better clarity from this month onwards. Are you able to understand this? And thirdly, if there are any assignments or tests for that month, you will know at least 1 month in advance. So till now, we were only announcing it only 10 days in advance or something, but going forward, you will know it in the month beginning itself. So you have to prepare accordingly and be ready. So if you see this test part, the next week, what I've done is I planned tests. But since I'm announcing it a little late, so thinking from your perspective, what I've done is I'm not going to ask you any problems from the chapters that have been mentioned. It is clearly mentioned there, stating only definitions and derivations. If you take what are the 2 tests that are planned, it is magnetism and matter and the electromagnetic induction. You have to come here and write it during the class hours. Okay, it is going to be on, when is it? 25th and 27th, and 26th is going to be a study holiday. Is this point clear? I'll be sharing this tonight or maximum by tomorrow morning. I'm majorly explaining this for you to understand how you are supposed to have a look at the sheet. Okay, if I send it tomorrow morning, first thing is your parents will see, they will get tensed, like what the sheet is. That is why I'm giving you the clarity of what we are going to do. Evening, you have to explain it to them. Okay, if at all they have any questions. Is this point clear? Is this getting registered? Secondly, this is the most important point I wanted to stress upon. If you see, last week we shared a Google form asking what are all the revision classes you need. Like most of them have mentioned like almost the first 6 chapters, right? So it is difficult. Okay, it is difficult for me to again go through the concepts because we are already seeing that we are recording the session here and the classes are getting recorded provided in the app as well. Now I'm going to tell you what exactly we are going to do with respect to helping you. So one more challenge that might occur is I've seen in your school. So they are handling some other, you have some other portions for your school test, but I'm in some other chapter, right? I'm going to tell you how I'm going to handle those kind of cases. So listen to this. You also have, I know each school has a different structure because I go in the order of NCERT. I miss few classes because of the unavailability, right? But going forward, that is not going to happen. Apart from that, irrespective of whatever is going here, okay, here I'm going to go in my way only. I'm not going to rush for your school syllabus. If I do that, I'm doing injustice. Make a note of that. You'll not know the pain today. You will curse me in the month of November or December that I rush through it. I'm not going to do that at all. Okay, so I'll go in my pace, but I'll ensure that the syllabus is completed by October end. Comfortably, you trust me on that factor, leave it to me. Okay, all that you have to do is only study. I'll tell you how you're supposed to follow that pattern. Last week, some of you have filled the Google form, right? Like I'll show you, we have all the responses. This is a response I've taken from the 11th standard, which we have worked upon. I'll work on the same pattern for 12th standard as well. Okay, it will be given to you. Trust me, it give me 2-3 days time. That's it. But I'm going to explain you how the sheet is to be observed so that you are able to make the maximum use of it. Let us say, see, like you have asked for the 5th and 6th chapter, right? You asked for the 5th and I saw that some of you have asked for the first 3 chapters, right? So for that, I'll tell you how the app can be used and how our YouTube channel can be used. I'm going to tell you now. Listen to this. So the responses we get, this we send a Google form. Just to give you some technical knowledge, right? So the form responses, generally we get something like this. It will get, if you know how it comes like this with the timestamp and everything. I'll tell you with the example. So the name of the student is Nivedita Arvind. She is from DAV Public School. This is our 11th standard student. She asked me stating that she needs revision with projectile motion and motion in a straight line channel. Okay, all this data below this is not provided by her. All that she entered is projectile motion and motion in a straight line, and revision topic for math is relations and functions and permutations, right? And for chemistry, she didn't enter it, right? After that was entered, I'll tell you what is the support we gave from our side. So what were the topics she asked for? Motion in 1D and projectile motion, right? So I have segregated it according to the order of the chapter in the textbook. So chapter 3, motion in 1 dimension, right? There is a clear-cut description of each subtopic. So when I say motion, if you guys come and tell me I need revision of current electricity, I'll not understand which subtopic you want. Is it like current electricity you didn't understand at all? Or is it a subtopic that is bothering you? Wheatstone bridge is bothering you? Kirchhoff's law is bothering you? I don't know. Each of you will have a different kind of a problem that is going to happen, right? So for that, what is there is, we have broken down all the lectures in the order in which it is handled here. So those lectures have already gone to this location. We'll tell you where we are uploading those videos. These videos have gone into the YouTube channel, the official channel, for which the link has been provided. So you need not go and search in the channel. We have provided the link, motion in 1 dimension playlist link. If you click on that, all these videos will be there. Okay. In a similar way, for motion in a plane, we have again segregated into simple things like vectors and projectile motion. Right? Actually, that is one chapter only. Vectors, we wanted to deal it separately because that is another concern raised by them. I'm sure you also will have some problem with vectors. Like some of you might have problem with not knowing when to apply parallelogram law of vectors, when to apply triangle law of vectors. That is natural. I've seen people like that. So that is why it is broken into 2 parts, vectors and projectile motion. In that it is, the lectures are mentioned and it has gone into the app. In the app, if you see which folder it is present in the recorder. I'm not sure how many of you are actually going through the videos or how many of you even have information about it. Okay, unless I have this data, I cannot help you. So why I'm showing this to you is if there is a chapter which is there for your school exam, but I have not completed here. First point I would like to stress upon is don't get tensed. We have it covered. In the sense, I might not teach you personally, but the videos are already available. Am I clear with that point? So videos are available. Only if you keep us informed, I'll be able to help you. Us in the sense, don't directly tell me there is a process for it, because I don't sit and upload all these videos. My work is only to teach here. You see the recording is going on and to take care of you guys. Someone else is working on it. So please keep them informed, right? Either through WhatsApp message, or you can put it in the suggestion box. I've already told you, but I would suggest drop a WhatsApp message so that we'll understand. If you let us know, we will try to break it into chunks and give it to you. I'll tell you how that is covered. Okay. Are you all using the app? Yes or no? See, this is admin access. You will not be able to see this, but you can still use the app through web also. If at all you want to upload any assignment or something, you need not do it only through the phone. You can upload it through this portal also. It's called web.classplasapp.com. There you have to go and enter your number and then log in. Okay. So in this, I'm not going to take you through the app demo. The only thing is I'll go to the video section. So in the video section, you would have seen the same thing gets replicated in your app as well. So you have the live class recordings, paper discussion, and pre-recorded session. Can you tell me what that live class recording is? These classes which are getting recorded, no, it is actually not this lecture, the one which is getting recorded through Zoom. If you see, we'll only get the screen recording for it. That is given the next day immediately, only for you to for us to ensure that if there is anything that you have understood wrong, if you didn't make proper notes out of it, you can always go through the video, but it is going to be a 1 hour lecture, right? It is going to be, let's say, so you would have seen till the last topic, we have completed 5 lectures based on this, means I've handled 5 classes. You will have clarity of this also. So I completed AC containing only resistor. So everything is mentioned here, right? So you can always go through this in the live class recording. Any idea about what this paper discussion is? I have not yet started actually, but I have a plan of doing it. Because of unavailability of time, I have not started. Going forward, after we complete the syllabus, I'll tell you what is the pattern. In the month of, from the month of November, our job is only to conduct tests and discuss those papers. Right. So that will not be uploaded under live class recordings, because for tests and papers, assignment centers, you will need quick revision of it. Suppose you get doubt with any question, you need not wait for us or wait for a reply. Everything will be available in the paper discussion section. Okay, let's say there is a question paper which contains 70 questions. I'm giving an assignment, for instance. Let's say I'm giving 1 week time, per day solve 7 problems. I'll try to ensure that the solutions are given there. If it is not there, you can approach us. So I'm not promising, okay, I don't want to overpromise also, because it's a tedious work. Okay, I don't want to overpromise. But if it is a live class recording, that will directly go under which one? It will not go under the live class recordings, it will go under paper discussion. So under paper discussion itself, 2 things will come. What is it? Assignments and tests. So we are giving you weekly assignments, right? But we have not uploaded any video solutions for it. Till now, we could upload only PDFs. Are you getting the PDFs, the study materials tab? So we are trying to add the video solutions also, so that you need not depend on us. Apart from that, this pre-recorded is the one which I'm saying it will help you. So you can ask me how it is going to help you. For example, if you see the chapters that are there, all these things are something that I've already completed, right? So these things are completed. If you observe, one of the students approached me in the beginning of the year and told me that she needs help with ray optics. It's actually there. So in the ray optics part, what I've done is it is broken down into multiple lectures. But here, see, it is the previous year lectures that we have pulled, but I'll show you another folder. Just give me a minute. Okay. So pre-recorded, see, for example, if you look at this one, no, there's a batch one. So in batch one of the schools had 10th chapter, that is wave optics, which have not completed, right? So if you go to this wave optics, right, the lectures are broken in this way. You have to go and filter it according to the name, so that you will have everything like this. Let's say you have doubt with Huygens principle, you don't know what to do with it. Just go there, you'll be there. In 9 minutes, you'll be able to learn it. Okay. Are you able to understand? So all these things are edited. For example, laws of refraction based on wave theory, Snell's law derivation, 6 minutes you will understand. All that you have to do is just go through that and make notes out of it. You should look at it with patience. I'm saying that I'm just sharing it so that you need not get tensed. Because one of the major concerns I keep hearing, when you are not there, we try to call parents and understand if you need any help. They are completely clueless. So that's how it works. They don't know anything about the subject. That is why you're coming here. There is no. But unfortunate thing is, we all are logged only during this evening times. I get only your evening times. Had it been in morning, I would have spoken to you directly, understand what is the problem. So what I'm saying is, you have to approach this. Don't have this inhibition saying that if I ask something, he is going to scold or something, nothing of that sort. We're here only to help you. And if you give me right, try to understand it is not only helping you, we are actually helping others also who for next year. Because we are creating a repository. You see the work that is going on, right? There is a lot of work that is going on. This repository will help you. Actually, you can ask me, sir, these recordings you're doing, but you're not giving us on time. Because I'm not targeting now, I'm targeting for the test series. Means by the time we come to November, everything will get edited and come in the app. So at that time, you need not ask me anything. Everything will be there. Trust me on that fact. Am I clear with this? Right. So any chapter in your school, it is not completed here, please let us know. So whichever, let's say I give you the previous year recordings only. One thing we'll check is the audio quality. Sometimes I'm telling you that also because last year we didn't have this level of technology. Okay, when I didn't use mic or something, so my voice will break at certain points. I'm telling you this also. Okay, so it will break, but I'll try to break those parts into smaller chunks and give it to you, so that at least go through the video and make a proper notes out. The reason why I'm saying asking you to go through my videos because you're used to my way of teaching now. I can say you go and watch some other's video on YouTube, but it will be completely different. See, I've injected some kind of a thought process into your mind. You'll understand if you see my videos. Okay, the promotion nothing of that sort. It's only to say that we are there only to help you. That is why I'm saying watch mine. If you don't understand, reach out. These are the two things you need to do. Am I clear with that? Okay, slowly I'm working on giving you a tracker also. I'll give you a template. Or a template everybody knows to use Google Sheets. This one, the one which I showed. You have Google account, right? You know how to use Google Sheet. I'll give you a template. You create a calendar for yourself. You have time, right? This is which September, October, November, December, Jan, Feb. You have 5 months. In 5 months, how are you going to target so that you're stress-free? At the same time, you're able to crack your board exams also. You can do it on your trust. I'll give you that template. It's not going to work only for just because you're coming here only for physics. I'm not going to say it's only for physics. I'll help you with other subjects also. I'll tell you how you're supposed to plan your study so that you don't pile up things till the end. I understand from your end, there is a problem because I'm handling something, your teachers are handling something, you have record work, you have other assignments, school assignments. I understand everything from your side. But whatever best is possible from my side, I would like to. If not me, you can approach our team also. Let's say you're stuck with something. So you're tensed, physics is scaring you. Don't have it within yourself. Don't have it within yourself. Don't have unnecessary thoughts in your mind. Don't put yourself under stress or go into depression. Don't do that. 12th standard is not worth your thoughts. I've crossed that stage and only come. I'm telling you honestly. Okay, I hope you're able to understand what I'm trying to say. Don't put yourself under any kind of pressure. Especially for studies, it is not worth. It's not worth at all. Your life is more worth than that. You can achieve something in your life. Okay. Don't put yourself under anything. There is a reason I'm telling. I'm not sure how many of you have heard the news that came in the morning. Please. It's not worth it. Clear? So anything is there, please approach us. Any kind of counseling, you get stuck with something, Personal problem also, please approach. There is nothing. If I know solution, I'll give it to you. Else, I'll put you through some specialist. I'll connect you to some specialist. I'm assuming there is nothing of that sort, but it is my responsibility to put it in a public forum. Okay, because I'm standing in that position. I'm assuming that you will value my words. Okay, so please. Clear? You will understand there is nothing, okay? Nothing to get tensed. School test, everything keep it aside. Whatever help you need, approaches. Whatever best we can do, I'll do it and give. But if there is time, I'll request you that also. You will not time when சொல்லிடுவேன். I'll not say இன்னைக்கு வந்து சார் and 5th chapter videos வந்து என்னால கொடுக்க முடியும். Because we have a priority of editing and our team is small. You see how many of us work. Our team is very small. Okay. I will take some time, but I'll definitely give you. So another what I would suggest is be proactive. For 10 நாள் கழிச்சு exam இருக்குன்னா at least let me know 10 days before so that I can edit and give you in 3-4 days. We'll prioritize that. We'll try for keeping you in mind. We'll prioritize that and give it. சரியா? அது மட்டும் பண்ண முடியுமா? Can you do it? That's it. It's that simple. Okay. Am I clear till this point? Any other questions? Right? You will get a document which I shared. No, this one. This one. I'll send you this also in the PDF format. So grade 12th also we have consolidated the data. We have already worked on it. Only thing is we need to put this kind of a structure and give it to you. That is taking time. This part is done. இது கொஞ்சம் time எடுக்கும். Okay. பண்ணி கொடுத்துருங்க. Clear? So another first 3 chapters without doubt இருந்தா you can always go through the pre-recorded part. அதுல எல்லாமே இருக்கு. தெரியலனா you can ask us. சரியா? Shall we proceed?
Sir.
Till where did we see that? What was the last topic? LR. LC LR. அதான் AC circuit across LR LC. LR பார்த்திருப்போம். This one ada. இதுவா பார்த்தோம். This is RC da. This resistor and inductor. Okay. Do you guys remember these things? Yeah. I need to get one file alone. Just give me a minute. Shall we proceed? Yeah. So write down this heading now. So write down the heading as series LCR circuit. The topic we are going to see is series LCR circuit. So here L stands for inductor or inductance, C stands for capacitance, and R stands for resistance. So what is the meaning of this? Here we have a circuit which consists of these three passive elements. What are they? Resistor, capacitor, and inductor. And how are they connected? They are connected in series. So the circuit is going to look something like this. So it is basically called as RLC circuit also. By the way, I generally call it as RLC because it's easy to remember. Resistor, inductor, and capacitor, right? So before we proceed with this topic, the prerequisite is you need to understand or you need to recollect the fact in which case is the voltage leading the current and in which case is the voltage lagging the current. So these are the two facts that you need to know. We have already seen it in the previous case itself, right? Now here, the first thing, wherever you see series, what comes to your mind? So series means same current. So what is going to happen across all these three passive elements? The current is going to be the same. Let me call it as I. Okay. So across the resistor, current is going to be I. So across the inductor, the current is going to be I. And across the capacitor, current is going to be I. So it is going to be R, L, and C. Right? Now the question is, what is the relation between the phase angle of current and voltage in the case of a resistor? They both are in same phase. In the sense, they both are supposed to be parallel to each other. They're supposed to be parallel to each other. What about the case of an inductor? So an inductor, which one is leading the other? So voltage will lead the current by pi by 2. Means voltage should be in the upward direction. This voltage, I'll call it as VL, and this voltage, I'll call it as VR. So it is understood that it is a voltage across the resistor and the other is a voltage across the inductor. So what about the next one? So across capacitance, the voltage is going to lag the current by I. So voltage will be downward. So it is VC. Okay. Now what we need to do is, since the current is going to be the same for all, we need to take all the voltages and combine and draw it in one phasor diagram, so that we'll understand what the resultant going to be. Right. So shall I do that? If you observe, VR is to the right, VL is upward, VC is downward. Have that in your mind. So which one is leading? Across all the three voltages, which one is leading? VL is leading, VC is lagging, and VR is in the middle. Same place, right? So having said this, if I draw the phasor diagram, right, what am I going to do? I'll draw the phasor diagram. So when I say phasor diagram, what is that we supposed to do? Take this as X and this as Y. This X dash and this is going to be Y dash. Now tell me. So if I take VR to be in this direction, where I'm saying VR is making an angle of omega t. See, there is a reason why I'm drawing it like omega t is because VR, I cannot draw it completely along X direction. Because what is the current across the resistor? I is equal to I naught sine omega t. That omega t is the actual angle made, right? So when you say VR and IR in the same phase, then omega t should be the angle made by VR with the x-axis. In which direction? In the anti-clockwise direction. So with respect to VR, how much is VL? VL is leading. I told you in the diagram, VR was like this, VL was like this, VC was downward. So if VR is like this, VL is at 90 degrees. In which direction? In the anti-clockwise direction. So VL should come in this direction. Make sense? Right. Then what about VC? With respect to VR, VC should come in the clockwise direction by how much angle? By an angle of 90 degrees. So can I call this as VC? Right. So the ultimate aim of we drawing the phasor diagram is to find the resultant using the parallelogram law of vectors. Right. So what we need to do is here, if you observe, VR is one vector, VL is another vector, and VC is another vector according to this phasor diagram. So I need to make it as a phasor diagram consisting of only two vectors, for which this VC, I will change the direction and put it in this way, so that it becomes minus VC. See, if this is VC, the reverse of it is going to be minus VC. So I'm going to draw an equivalent diagram for this, which looks like this. This is going to be VR, which is making an angle omega t. What about this? It is going to be VL minus VC. Now I have only two vectors which are collinear. Sorry, the two vectors which are co-initial. Now I can apply the parallelogram law of vectors. So when I apply parallelogram law of vectors, the resultant will be in this direction. It is Vz. Now tell me, what is the relation between Vz, Vr and VL minus Vc? So Vz square is equal to Vz square. I already wrote it as square. Vz square is equal to Vr square plus VL minus Vc the whole square. It is plus. This plus VL minus Vc the whole square, where here I am assuming VL is greater than Vc. That is why I reverse the direction of Vc. Here, what is the assumption? VL is greater than Vc. Makes sense? Am I clear till this point? So VR square, Vz square is equal to VR square plus VL minus Vc the whole square. Okay. Now, listen to this carefully. Sorry. Yeah. Now here, if you observe, okay, I'll do one thing. Yeah. So here, if you observe, Vz square is equal to Vr square plus Vl minus Vc the whole square. But we know that Vr is equal to I into R. So am I right? This is IR square plus what is VL? I into XL minus what is VC? I into XC the whole square. But what is VZ? VZ is I into Z the whole square. What does Z stand for? Z stands for the impedance. So when will you talk about impedance? Impedance can be spoken only when you have a combination of resistive and a reactive element. If it is only reactive element, what are the reactive elements that you already know? Capacitor and inductor. If it is only capacitor or only inductor in a circuit, you use the word reactance. If it is only resistor, you use the word resistance. If it is a combination of resistor and inductor, you use the word impedance. All the three are related to the opposition offered by that particular combination to the flow of current. Am I clear with that? So listen to this. So if I take I outside, I square into Z square is equal to, I'll take I square outside into R square plus XL minus XC the whole square. Makes sense? So I square and I square are gone. Z is equal to root of R square plus XL minus XC the whole square. So this is going to be the value of the impedance for whom? For a series LCR circuit. In the sense, you can replace that RLC with this much value of a device to do the same work done by all those three. That is the meaning of this impedance. Right? You will find this word impedance whenever you try to buy these kind of electrical devices like fans or tube lights. You'll see the word impedance. As I told you, the other day, you can go to the Amazon and have a look at it. You'll see that word. That will be written in terms of ohm only. Because impedance is also opposition of it, right? It will be in terms of ohm. Am I clear till this point? Right. So are you all done copying this or you're doing it? Not it? Okay, please copy it. So from where should I show? First slide. Idwa. Right. Make it fast. So the value of Z comes out to be root of R square plus XL minus XC the whole square. Okay. Now the question is, right, if I have a series, R, L and C circuit which is connected across an AC source like this. Right, what do I have? A series RLC circuit which is connected across an AC source in this way. So what is ultimately happening? Because of this voltage, there is some current flowing through this circuit. Now I'll ask you one question. Tell me, think and tell me the logic. So if I keep changing the value of R, L and C, do you think the amount of current that is flowing through the circuit is going to change or not? Listen to this. E is equal to E naught sine omega t. Right? Listen to my question very carefully. Let's say I have a device. Okay. Imagine that something like this is existing. I've given a plate, okay, in which there is R, there is inductor, there is capacitor. Right? Assume they are variable. Variable in the sense, I'll give you a screwdriver where if you turn the screw, the value of it will change. Have you all seen that variable adapters? You can connect it between 3 to 12 volts depending on your usage. Have you ever seen that? See, for example, you connect an adapter. Let's say there is a device which needs to take 12 volt inside. You can adjust it with the help of a screw, saying that you can put it 12 volt. That is an adjustable adapter. Okay, you can adjust it. Let's say I'm giving you a system of that sort. What am I doing? I have put resistor, inductor, and capacitor. All the three have the provision to change the value. So you're dynamically changing the values. When you keep changing the values of each, you're trying out different permutations and combinations. You're keeping the value of R fixed, L you're increasing, C you're decreasing. Then you're changing depending on your comfort, right? You're keeping on doing it. Do you think when this process goes on, the value of I will change? Do you think the value of current will change? I'm not asking, listen to my question carefully. I'm not saying will the value of the current change across resistor, inductor, and capacitor. I'm not asking about that. That value will be same. But I'm asking, is this I going to change? In the sense, let's say for a particular value of RLC, there is a value of 5 ampere flowing through the circuit. If I change one of the values, so there is a particular value of RLC, let's say 555, 5 ohm, 5 Henry, and 5 farad. Okay, some dummy numbers. For which the current flowing through it is 5 ampere. If I make that L from 5 Henry to, if I increase it to 10 Henry, do you think the value of current will still be 5 ampere? Answer is no. The value of I will still not be 5 ampere, it will change. Okay. Like this, what can happen is by you changing the different values of the passive elements parameters, what can happen is the value of I can be changed, where that I value can be written as I is equal to E divided by Z. Makes sense? What does that Z mean? I told you already. Z is the impedance. What is the meaning of impedance that you need to understand? Meaning I am replacing these three passive elements with some other passive element that has an impedance of the Z. So can I call it? So I is equal to E by Z, but Z itself is dependent on R and XL minus XC. So why will the value of I not change? So Z itself is dependent on these parameters, right? If you change the value of resistance, Z value will change. When Z changes, I will also change. Makes sense? Why am I asking this question? Because listen to this very carefully. There is one important term I'm going to introduce. Listen to this carefully. So I is equal to E divided by Z. You're not changing the value of E, but who's controlling the value of I? Z. But Z itself is controlled by whom? R, XL, and XC. So if I keep changing the value, there will be one particular instance. Listen to this. There will be one particular instance at which the value of I will be maximum. What did I say? You keep changing the value of R, L, and C. What will happen? There will be one particular instance where the current value will be maximum. And that condition for which the value of current is maximum is what is called as resonance. That is what is called as resonance. Are you able to understand this? Okay. So what is it? What do you mean by resonance condition? The condition where the current flowing through the series RLC circuit is going to be maximum. Okay, I'm very clear in my description. I'm talking only about series RLC. Okay. So just make a note of it and be back. Ashwin. Sorry. Yeah. So what was I discussing? Resonance. So what does resonance mean? In a series LCR circuit, the maximum current, right? When the condition where the maximum current is obtained is what is called as resonance. Now the question is, if this kind of a condition can be achieved, then what should those values be? I told you Z is dependent on these parameters, right? What should that value be so that you're able to achieve this kind of a condition? That's what we are going to see next. Now, what did I say? I is equal to E divided by Z. But what is Z? Root of R square plus XL minus XC the whole square. Now we need to start thinking in terms of mathematics. How is I and Z related? They are inversely proportional. So if I want the value of I to be maximum, Z should be least. So if Z has to be least, the least value that is possible under a square root is 0. So I cannot put 0 and say maximum infinite current is flowing through a circuit. That is not possible. And impedance cannot be 0 also. Right? Now, the question is, if Z has to be least, and observe, Z is the sum of two positive values. Does it make sense? Z is the sum of two positive values. What do I mean by that? Under the square root, I have square of two numbers. Square of two numbers or square of any number is positive. So it is a sum of two positive numbers. So Z cannot be 0. That is one thing. Secondly, if Z has to be least, either of these two positive value has to be least. It has to be in such a way that either R is 0 or XL minus XC the whole square is 0. right? So here I'm mentioning it as for resonance, Z should be least. Z should be least. For Z to be least, what should happen inside this? Either R should be 0 or XL minus XC should be 0. But I'm choosing XL minus XC to be 0. You can ask me a question, why R is not being taken as 0? Because for impedance to be defined, what do you need? You need at least one resistive element. If I put R is equal to 0, it will become an LC circuit. There you cannot define this impedance. Okay, there you cannot define the impedance. So that is why XL minus XC is 0. This clearly indicates what is XL? Omega into L. Minus what is XC? 1 divided by omega C is equal to 0. So when you rearrange this, what are you going to get? Omega square will be equal to omega square will be 1 divided by LC, which implies omega is equal to 1 by root LC. And this value is what is called as resonant. See here I use the word CE. Resonance. Resonance is a phenomenon. This is called as resonant frequency. And it is written with the subscript omega R. That R stands for resonance. Are you able to understand? So omega R is equal to 1 divided by square root of LC. But we know that omega can also be written as 2 pi F. What will you do? You can also write it as 2 pi F. So 2 pi into FR is equal to 1 divided by root of LC. That implies FR is equal to 1 divided by 2 pi root LC. Does that make sense? So omega R is equal to 1 by root LC or FR is equal to 1 by 2 pi root LC. Generally in a question, if they ask you what is the value of resonant frequency, you find omega R only. Okay. So this will be the value. Shall I proceed? Right. So listen. Are you all done writing? Yeah. Okay. See, listen. Now we understood what is this resonance. But the important question that we need to ask is, where is the circuit used in the first place? If you create any circuit, there should be some application of it, right? Now for this, I would like to connect it to your real life example. So everybody hears this FM, right? You know what is FM? You hear? What is it? What is the full form of FM? It's called frequency modulation. But you know what is FM, right? In your car and all, whenever you go, you keep listening to it. So it's called frequency modulation. So have you ever observed the name of the channels? How are they? They say 92.7. They have a number, right? What does that number represent? See, if I say
Hertz,
this,
sir.
sorry,
Hertz, sir.
it's not hertz, it's megahertz. Because you're listening to this, right? Next time observe it. Okay, when you're tuning that number, observe that. It will be written in terms of megahertz. So for means they will register that particular frequency for their channel. Actually, the name of their channel is 92.7 only, but they cannot say it as 92.7. They have to give a name to it. That's why they will call some radio Mirchi or something, some name they will give. Okay, but that's not the important thing here. So this 92.7 megahertz, it comes from the concept of radio frequency. You know what is radio frequency, right? So the one which is used for communication, even we are talking about the mobile phones and everything, right? There needs to be a certain frequency that is authorized. Authorized in the sense government has approved a certain frequency within which the communication channels can be established. That falls somewhere between 88 megahertz to 108 megahertz. I'll tell you why I'm telling you all the story. That is why if you look at all the channels named, right, all the channels numbers, they will fall only between this range. You will not have anything beyond that 108. 108 mala bocha, kida bocha, terrorist activity. Okay, that should not happen. So it's within this range. Now the question is, sometimes you would have tuned to 92.7 only, but there will be some hissing sound coming in. Have you ever observed that? So what is the first thing you try to do? You will try to adjust something. You will have a knob kind of thing. You will try to adjust. That is what is called as a tuner circuit. Obviously, it's used for tuning something. You are trying to tune it to the right frequency, so that you match it with that frequency or are able to hear. See, sometimes it can happen because of the antenna, the aerial not able to receive the signal also. But if it is able to receive, sometimes the sound comes, means it is exactly not sitting at 92.7. It is somewhere between 92.6 and 92.8. That is why you'll hear. You will try to use the tuner circuit to exactly bring it to 92.7. But the question is, who is giving this brain to understand that 92.7 should come there? That is what this series LCR circuit does. So if you observe, the application of that series LCR is mainly in the tuner circuits, right? So when you observe this, what is the most important parameter on which you concentrate? It is the quality. You want the sound to be perfect, or else some kind of, we'll get some FOMO. It is bothering us. We are missing something, right? So for that not to happen, this LCR circuit is the one which is used as a tuner circuit. Am I clear with that point? Right? So when this happens, right, what did I say we'll concentrate upon? We'll concentrate upon something called as quality. That is measured by a parameter called as QF, which is called as quality factor, or you call it as sharpness of resonance, or you call it as sharpness. Sharpness means you want the sharp sound to come, exact sound to come. You don't want any noise to get added. You want it to be filtered. Are you able to understand that point? So what does this quality factor or sharpness has to do with your theory part is, if you plot the graph showing the variation of, I as a function of omega is the frequency, right? Because here, what is the major parameter? It is the frequency we are talking about. So if you draw a graph between omega and C, you can observe that the graph is like this. Sorry, not like this. Sorry. So the graph is going to be like this. Now you're able to see there is a particular value of omega. There is a particular value of omega for which the current is maximum. Then what should that omega correspond to? That is what is resonant frequency. Am I clear with this point? I is maximum. I is maximum means I naught. Right. Now what I'm going to do is, on either side of this omega r, I'll be choosing two frequencies. Listen to those two frequencies clearly. Those two frequencies will be chosen so clearly, which I'll call it as omega 1 and omega 2, for which there is same value of current that is getting produced, and the current value will be 1 by root 2 times I naught. What is this 1 by root 2 times I naught called as? We know this already. We saw it somewhere else, the beginning. It's called as the RMS value of current. So This omega 2 minus omega 1, there is a difference. No, you're able to see a gap. This omega 2 minus omega 1 is what is called as bandwidth. Because there are bands of frequencies. It's not exact frequency. There are infinite number of frequencies that can exist between omega 1 and omega 2. That's what the meaning of band is. Width means obviously the distance between two. So that's why it's called bandwidth. Right? So if I am able to define a parameter like omega r divided by omega 2 minus omega 1, then this parameter is what is called as quality factor. So what is the omega in the numerator? The omega in the numerator is the one that corresponds to the maximum value of current. What does omega 1 and omega 2 correspond to? They correspond to the RMS value of current. So omega r divided by omega 2 minus omega 1 is what is called as quality factor. So what will be the unit for it? Obviously, no unit. It's going to be a number. That number will decide the quality factor. What is the other name for it? You can also call it as sharpness of resonance, because you want that sharp frequency to get generated. So tuner circuit's quality is decided by this. Am I clear with this? Right? So this is all about the concept of series LCR circuit and resistance. There is one subtopic left out in this chapter, which is about the power in AC circuit. That we'll discuss tomorrow. I will complete. So revise all these topics in come. What is the time now? Today I had a lot of discussion, so I could not complete this. But tomorrow be prepared for 15-20 minutes extension, something like this. I'll complete this chapter so that there is no pending. So those are online. Are you all clear?
Yes, sir.
Sir.
Yeah. So if there are no questions, we can wind up.
Thank you, sir.
Yeah. See you.
Thank you, sir.
Yeah, ma.
Thank you.
Thank you.